As we're doing spring break, just in case you can't find anything to keep yourself occupied over spring break, because I'm sure you guys will be incredibly bored. I'm going to open up all of your math lab. Okay. So math lab that's all been closed will be open until the Sunday night before we come back. Okay. So I think that's going to be like the 15th. I'm not sure. Whatever that Sunday is before we come back. A few of you had some issues with your account from last semester didn't get closed or something. So I don't know, but this will be your week to catch up on the math labs you didn't get done. All right, so we're going to talk about, can you all at home hear me? I'm getting a good echo here, and I don't know how to change it. And if I mess with it, I'm going to mess it up. And then, so tonight we're going to start talking about polynomials, 5-1. I hope you guys can see the screen. Start off with, we're talking about yes or no. Is f of x is equal to 5x plus 4x squared, is that a polynomial? Well, yes, that's a yes. Here's the thing, a polynomial is going to be in the form of y or f of x is equal to a times x to the n power. And it might have 3 or 4 terms in descending order, a times plus a times x to the n minus 1, right? We write these in descending order. A is any real number, but here's your qualifier right here, n. N has to be a positive integer. Okay, your exponents must be a positive integer. So if I were to write this in the correct order, I would say 4x squared plus 5x, because that's 2 and 1. The degree of this polynomial is 2. Whatever the greatest exponent is, that's your degree. Okay. What about 2? How could I put an x on there? I could. That's exactly right. I could say 8x to the 0 power, right? And then that's still just 8, because x to the 0 power is just a 1, right? So that's a polynomial. Yes, it's a polynomial, and the degree is 0. You need to be sure, guys, that you are advocating for yourself. I know there's a million resources out there, and it's real easy to say, I don't want to say anything in class. I'm just going to figure it out later. You got to speak up for yourself. Do not let me move on if I haven't covered something, you know. Why would number 3 not how else would I write that without that exponent, that x in the bottom? Exactly. If I were to rewrite this, that would be 1 plus 14 times x to the negative 1, right? Now my exponent is no longer a positive integer. So this is a no. And I chose the wrong problem for 4. I meant to have something else, but we'll go ahead and do it. This would be 1 minus 3 times, right? So that's again, no. Now there's another situation where you're going to say no. How would I write a radical, the square root of x, as an exponent? I have a power of 1 up under here, right? And this is the second root. So this is also written as x to the 1/2. So that's not an integer. So anytime you see one under a radical symbol, you're going to say, no, that's not a polynomial. Okay? No negative exponents, no fractional exponents. That makes sense, guys? All right. All right, so we're going to talk about an even or an odd exponent. So before I look at that problem there, I just want to talk about y equals x squared. Okay, or even for that matter, y equals x to the 4th, or x to the 6th, or x to any even number. Okay, now if it's an x to the 2nd, that's a parabola, right? Okay, no matter how big this number gets, I can say x to the 88th power. It's still going to hit 3 points every time. Every one of these are going to hit the same 3 points. We're going to have negative 1, 1. Because no matter how many times I multiply by 1, I never get off the 1, do I? 1 times 1 is 1, times 1 is 1, times 1 is 1. I mean, I'm never getting off the 1, am I? And if I have an even exponent, when I square a negative 1, it always comes out positive, doesn't it? Okay? I'm also going to always have the coordinate point 0, 0. And the third one, I'm also always going to have is 1, 1. Now 5, 1, we don't have a lot of calculation going on. We don't have a lot of mechanics. All we really have in 5, 1 is a lot of vocabulary. Okay, so I'm going to throw another one in here, and that's end behavior. Okay. Now our polynomials are going to start to look a little bit crazy. From the middle, they're going to start curving, turning back around, crossing it, touching it, going up, down. But the end behavior, when I'm talking about that, I'm talking about the very end of the graph. What is it doing on the very outside? Now, if it's even, 2, 4, 6, 8, a times x to any even exponent, and this is a positive 8, my end behavior is going to be both of them going up, right? I mean, you know that one. That's your parabola. And if it's even and I have a negative a, then what is that end behavior going to look like, guys? No matter what it's doing in between there, in the end, on both sides, the arrows are going to be going down. All right, we'll look at that a little bit more right now. Come on. Right now, let's look at, remember our transformations? What is minus 4 inside of the parentheses going to do? How does that translate my graph? Minus 4 inside of the parentheses. So that means that I have to take x and add 4. Because that's going to shift my graph 4 units to the right, right? What about that plus 2 on the outside? How's that shifting my graph? Up 2. So if I'm going left and right, that's messing with my x. But if I'm going up and down, that's going to mess with my, so I'm going to add 2 to the y. So we said, and we're going to get a little bit more detailed right now. Only thing we're going to focus on is those 3 points. We said if it's even, I'm going to hit the points negative 1, 1, 0, 0, and 1, 1, right? That's what my parabola y equals x squared looks like. But I have to shift it. So for x, I've got to add 4 every time. And for y, I've got to add 2. So I've got 3, 3, 4, 2, and 5, 3. Three, 3, 4, 2, and 5, 3. And you know you have positive A right there. So you know your end behavior is both of those going up. So far, so good? All right. What if it's not even? What if it's odd? Well, x squared is that parabola. What is your cubic function? What if it's odd? What does the y equals x to the third power look like, guys? That's where I'm coming down through there, yes? All right. Once again, I don't care. Any odd. Y equals x to any odd exponent, I'm going to have negative, excuse me, -1, -1, 0, 0, and 1, 1. My end behavior, for y equals a positive ax to the third, down on the left side, up on the right side. If I have y equals a negative ax to the third, it just gets flipped over, right? Know that end behavior business. I don't think I've seen a final exam without a question about end behavior on polynomials. So know that one. All right. For me, please find my next three. Translate it. What are those three coordinates going to become? So what is that -2 going to do? For my x's, right? And then that +3. It's only inside that it does the opposite. So I've got 1, 2, 2, 3, and 3, 4. 1, 2, 2, 3, and 3, 4. Wish I was a little bit better at my freehand. Like I said, I know this is a lot. It's just vocabulary. It's stuff that you're going to have to make it stick up here to answer these questions. Okay. When you see that word zeros, I wish I could get rid of this echo. Where'd you go? Oh, there we go. You already know these. They're your x-intercepts. Those are your zeros. Now remember writing the quadratic equation from the solutions? That's all this is. If I have a negative 3, that means that I have x plus 3. If I have a negative 2, I have x plus 2. And if I have a 3, I have x minus 3. Zeros is another word for your x-intercepts. When is y 0? At the x-intercept. Okay, just another vocab word for it. So now I'm just going to FOIL them out. And I'm going to take that x plus 3 times that x minus 3 to start with. Because what shortcut do I have there? Yeah. So that, because my center terms on there are going to cancel each other out, aren't they? Because I will have a positive 3x and a negative 3x. So this gives me x squared minus 9. And I still have that x plus 2. So that's going to give me x to the third power minus 9x plus 2x squared minus 18. I'm going to rewrite it in descending order, right? So I want x to the third plus 2x squared minus 9x minus 18. Now, what do we know? If I have to put this, and we're going to be putting these on the graph, but I mean, tonight we're just doing a real rough sketch of it. I know that I have a negative 3, a negative 2, and a positive 3 for x-intercepts, right? Now, I also know that I have a degree of 3. So that's odd. So what does my end behavior of an odd polynomial look like? What does that cube function look like? Right up, left down, right? My end behavior. Feel like I'm about to do the, what's that dance? You guys don't know. You've probably done it in costume. Yeah, that too. No, yeah, staying alive. Oh my goodness. All right. What else do I know, guys?
Yeah, it's supposed to be up on the left, down on the right. If it's a negative, it's a negative odd thing.
But it's not. My A
Oh, never mind. You're right. I'm sorry.
is job though. Watch it. That's good. All right, so I know the end behavior. There's another piece of information staring at me. These points are my x-intercepts. I know that my y-intercept is negative 18. Like I said, I'm just doing a real rough draft here. Okay, another vocabulary word. Turning points. How many times will my graph turn? 1 less than the degree. So if I have a degree of 3, this graph is going to turn 2 times. So it's going to come down, and it's going to go down to negative 18 and come back up, cross over again at the negative 2, and I don't know how high up it's going to be. I do, it's going to go up to 12 something, but then it's going to come back down. Okay, 2 turning points because the degree is 3, and it's 1 less than the degree. Come on. 1, 2. Okay. All right, let's see what we can find out for number 8. First of all, let's try to, and that should say 3 there. I don't know what happened to the 3. Let's try to write the polynomial out. Mamouche, have you been able to get into your lab? Okay. hard with just writing those binomials. FOIL them out. Remember, like, if we had, all right, the quadratic equation, my solution was 3 and -2. Write me the quadratic equation. We would say, all right, well, this is x minus 3, and this was x plus 2. And then we FOIL that out, and we get our quadratic equation. X squared minus 3x plus 2x minus 6. So remember, we had to set these equal to 0, so I'd get a positive 3, right? I knew I had to do just the opposite of those. That's all you're doing here. You're not doing anything different. I have an old costume in my closet. What would you guys think if I showed up to teach class one night and I was in a 70s disco outfit?
I would love it. I think you should do it. I really would.
Do it next.
Or
Be
Wednesday
like,
after.
surprise.
Y'all would have to get up and dance.
Oh, I'll get up
I
there
would
and
dance
dance
with
with
you
you.
so you wear it. I would dance.
I'll do it.
I had hair like way down here. Now this is like more like the 80s, but my hair was like all the way down, and I'd put it in braids. So I mean, when I'd take it out of the braids, it would be just like,
You need to bring it a picture. I want to see it.
there are things I never want to see again. The day was fun, but it was back in the day.
I would give anything to live, just be back in those days.
You guys should do days. Are you in a sorority? So you have like your
Yeah, we
period
had
days,
something.
where you.
Yeah, we had some sisterhood thing, and I think it was 70s. But it was fun.
Now, 70s, I had a lot of stuff because that was my older sister's, but mine was the 80s, and I just dressed in rags all through high school. I mean, we ripped everything up and tied it on ourselves somewhere.
Huh.
So weird. And hair. Gotta have big hair. All right, how'd we do? All right, let's see. I wish there was a better way of erasing all of this. So because I have a -2, that gives me 5 plus 2, yes? How about like that? So I've got, come on, x plus 5, x plus 2, x minus 2. Well, again, I got something of a shortcut there. Yeah. So that's going to give me x squared minus 4. So x times x squared gives me x to the third minus 4x plus 5x squared minus 20. X to the third good. What's that 20? That's your y-intercept, right? Okay, so when I go to graph this, I've got in behaviors -5, -2, +2. got to be there. 2 turns. This is going to come all the way down to 20. Now let me ask you this. What if we get into, how could I find out? This is going to go up and then come back down, right? It's going to go up to that maximum. How can I find out that maximum? I want to know, because I know that this is coming down to negative 20 and then coming back up. And it's going to go back up, come to a maximum point, and then come back down. How can I find that out? What would be my midpoint right here? How could I get midpoint? Got to go back all the way to chapter 2. 2:1. So this is negative 5 plus negative 2 divided by 2. So it's a negative 5 and a negative 2 divided by 2. Y'all gonna have to get that calculator out because this is, I'm gonna make you do some much bigger numbers here in just a second. Negative 7 divided by 2. Negative 3.5. That's my x. I need my y. If I have my x, how am I going to get my y? There you go. I'm going to plug it in. All right, so I need you to, because I can't do this math on my own, I need negative 3.5 to the third power plus 5 times negative 3.5 to the second power minus 4 times negative 3.5 minus 20. Does everybody understand where I got that 3.5 from?
So you take the first 2 and put them over the third one. Is that how
No. Oh, yeah. I can see why you say that, but no. No. I'm trying to find the middle. This is going to go up and come back down, right? So I want to find out how high it's going to be. So I'm finding the dead center between negative 5 and negative 2. So how do I find the midpoint between 2 other points?
Okay.
Add them together and divide by.
But will it
2.
always be the first 2?
It's going to be the 2 that I want to find out. Like if I didn't know this was negative 20, I'd be using these 2.
Okay.
All right, find that midpoint. So negative 3.5 raised to the third power. What do I get? You got a y to the x or your cat button. Like negative 3.5 to the 3, something like that. I think it's 40 something.
42. Do you want us to round?
You can. Like I said, tonight we're just doing some rough drafting of what our graph is going to look like. All right, how about negative 3.5 to the second power times 5? What do I get for that?
Negative 69. 25.
Okay, and that negative is inside the parentheses. So that's going to make that a positive one, right? And then negative 4 times negative 3.5, 16. minus my,
I got 14.
yes, 12 and 2 is 14. Shoot. Plus 14 minus 20. And when I get all of that added up, where do I end up? Think about 12.6, 5. So I know that I have the point negative 3.5 and 12.5. Oops, I forgot that they won't, if I'm writing on there like that, it won't show up on the screen for at home. Okay. One more. We got another vocabulary word here. Multiplicity. Okay. When I have a 0 of negative 5, that gives me x plus 5 in parentheses, right? Multiplicity is giving that parentheses an exponent. Okay? This is x minus 4 with a degree of 1. The multiplicity is the degree on the outside of that parentheses. It also tells me something else. Okay? If my multiplicity is even, I am going to touch the x-axis. But if my multiplicity is odd, I'm going to cross the x-axis. When I FOIL this one out, I've got x minus 4. This time I don't have the difference of squares, but I have the two perfect squares. So I've got x squared plus 10x plus 25. X to the third, 10x squared plus 25x minus 4x squared minus 40x minus 100. Got some cleanup to do this time. X to the third. Then I have a positive 10x squared and a negative 4x squared. So that gives me plus 6x squared. Minus 25x, a positive 25x and a negative minus 100. So it's a degree of 3. So I've got my points going up and down, right? It's going to turn twice because the turning point's one less. But the one thing I know new now is when I get to this negative 5 and this positive 4, I'm coming up here. But at negative 5, I'm not going to cross over. This is going to come down and go all the way down to a negative 100. Come back up. But it's not going to cross that x-axis. It's going to touch that x-axis and turn back down. because that's a 2. The multiplicity of this -5 is an even number. And when it's an even number, that says you're going to touch it and go back. Okay? All right. Looking at problem 10. I'm going to be at -2 and +3, right? I have 2 x's here and 1 here. So the degree of this polynomial is going to be 3, right? At the -3, at the 3, I'm going to come down, touch, go back up, and come down and cross. That's even. So that says you're going to touch and go back. This one is a 1. That's odd. So that says you're going to cross over that axis.
How did you find the degree?
If I FOIL that all out, I'm going to do x times x here, right? And that's going to get me an x squared. And I'm also going to do times another x here. So that's going to give me x to the 3rd. Okay?
You have to like FOIL it out first before you do that.
You can count them. I've got 2 x's here and 1 x here. Right? No matter how many times, you just look through it. How many times are you going to multiply by x?
So like 1104.
Yes. But now 11's got kind of a tricky business going on. Could I set x squared plus 3 equal to 0 and get a solution? No. That might have a multiplicity of 1 right there. But what happens when I say x squared plus 3 equals 0? What happens when I go to solve something like that? Subtract that 3 from both sides, and x squared is going to equal to a -3. Does that have a solution? No. You can't have a square equal to a negative, right? That doesn't mean the whole thing is just bogus. That means that my curve there is going to happen without touching the x-axis. All right? I do have at 4 with a multiplicity of 2 with the end behavior of them going up. So the image is going to come out something, touch, go back up, curve, and somewhere, and I'm not saying it's going to be there, but somewhere it's going to come back down and curve again without getting to the x-axis. Why is it not going to get? Because I can't take the square root of a negative number. That is not going to be. There's my end behavior because it's even and positive. Yes? All right. Just getting a little bit redundant here. Zeros are x-intercepts, right? So when this is asking me for the x-intercepts, all right, 3, 0, -3, 0. 6, 0, and negative 6, 0. Zeros are my x-intercepts. It's the same thing where I cross the x-axis. Now, what do I know about the y-intercept? X has to be, right? So I could say 0 plus 3, 0 minus 6, and 0 plus 6. What am I going to end up multiplying? So I'm looking for my y-intercept. All I got to do is multiply those numbers. When x is 0, I have the y-intercept. Negative 108. Better check my crazy math, guys. What about 13? My x-intercepts. Negative 1, 0. 6, 0. And 1, 0. At negative 1, my graph will cross over that x-axis. At 6, it'll cross over that x-axis. But at positive 1, it's going to touch that x-axis. What about be careful of the signs now. What about my y-intercept for 13? Y-intercept is going to be, I heard you. Right? Be careful because that's going to turn into a positive 1 there, right? So let's look at problem 14. What's the degree of 14?
3.
So looking at these graphs, if I have a degree of 3, which two of these graphs could I throw out?
B and C.
B and C. These are even, aren't they? So that's gone, and that's gone. Now, which one do I want to choose? Look at that. Look at your A. Do I want A or do I want D?
D.
Yep. There's my end behavior for positive A. Okay. One more. How many x's am I going to multiply here? 4. So I have an even function, right? And A is, so what's my end behavior on 15 going to be? This is odd. This is odd. And this one has a positive ax squared, not a negative. Right? Okay? All right, guys, that's what I got. Any questions at home?